Hello everyone, I am Jayant Teotia, a first year PhD student at NTU Singapore, and I'll be presenting the paper Evaluating Vision Language Models in Detecting Learning Engagement, co-authored by Dr. Shulang Jiang, Dr. Ray Mao, and Professor Eric Cambria. So first, I'll discuss about the background and the research questions posed in the paper. Then I'll discuss the contributions made. In the methodology section, I'll first discuss about the datasets that we have used for the evaluation, then the VLMs and their setup, and the prompting strategies. There are two kinds of experiments and analysis that we have performed. First is binary classification, that is for polarity and engagement. And the second is categorical analysis, which is for the various emotion classification and student classroom behavior. Finally, we'll wrap up the presentation by discussing the conclusions. VLMs have rapidly been used for various detection tasks like polarity detection, emotion detection, etc. However, there is a limited research in the engagement detection part with the help of VLMs. It's important to monitor mental and cognitive states of students in a classroom because that can help in providing support for students' engagement and well-being. Despite the recent advancement in multimodal emotion recognition, current VLMs might still not be adept at recognizing classroom setting behaviors of students like engagement, distraction, absent-mindedness, etc. This is because such emotional states are more contextual and require the machine to understand not only the facial expressions but also body language and classroom related activities. So there are two research questions that we pose in this paper. First, compared to conventional visual emotion detection tasks, are learning engagement detection tasks more difficult for VLMs? Second, what are the most challenging factors for VLMs to process learning engagement detection tasks? The contributions of this paper are as follows. We provide a systematic empirical evaluation of two state-of-the-art VLMs, namely Lava V1.5 and GPT-4o Mini, in the context of detecting learning engagement, addressing a gap in the existing literature regarding their effectiveness in classroom-specific emotion recognition tasks. We identify and discuss specific challenges that VLMs face when processing learning engagement detection tasks compared to conventional emotion detection and suggest potential avenues for improving VLM performance in learning engagement analysis. For our experiments, we have curated 3 datasets from 2 existing public datasets that are SCB3 and Emotic dataset. So the first is SCBC dataset, that's a learning engagement dataset. It consists of 5 classroom behavior classes: reading, writing, using phone, bowing down the head, and leaning over the table. It is further classified into 2 classes: concentrating and distracted. The second is Emotic C, that's a sentiment polarity datasets. It consists of 5 emotion classes: affection, pleasure, anger, sadness, and fear, which are further classified as having positive and negative polarity. The third is Emotic E, which is a journal engagement dataset. It consists of 2 classes: engaged and non-engaged. In this slide, you can see the example of the 2 datasets, SCBC and Emotic C and E. In this table, you can see the distribution of various classes in these datasets. SCBC, Emotic C, and Emotic E contains around 2000, 1500, and 1000 images respectively. We have used 2 VLMs for evaluation, Lava V1.5 and GPT-4o Mini. Online API is used in the case of GPT-4o Mini, and Lava V1.5 is implemented offline on NVIDIA A100 GPUs. All the images are resized to 128 x 128. This is the general framework of prompts that we used for our evaluation. For example, for learning engagement detection, the prompt is: suppose you are a teacher. Given the following image, identify if the student is concentrating on the studies or not. Answer in yes or no only. Yes if the student is concentrating. Moving on. The first experiment that we have performed is binary classification and analysis. So it is concentration and distracted in the case of SCBC dataset. For Emotic C, it's positive and negative polarity. For Emotic E, it's engaged and non-engaged. In the table, we can see that both VLMs achieve higher accuracy in sentiment polarity classification datasets that Emotic see. Performance drops are greater than 15% on engagement analysis tasks for the other two datasets. This might indicate difficulty in engagement understanding of VLMs due to the absence of advanced contextual reasoning. For example, a person using a phone might be considered engaged, but a person using a phone in a class is considered as distracted. Next, we move on to categorical analysis for SCB-C dataset. Here, the highest accuracy is achieved in the writing class by both the models, and the lowest accuracy is achieved in reading, bowing down the head, and leaning over the table, especially by the Lava model. The actions in these classes are highly dependent on situational context, like bowing down the head while reading, which might be difficult for VLMs to classify. For the Emotic-C dataset, if we compare the tables of the SCB-C and Emotic-C datasets, we can see that performance gaps between highest and the lowest accuracy labels have decreased here. It might be due to the greater number of emotion detection instances in pre-training phase of VLMs. It's easier to find a picture with a person having a sad face with a caption that I'm feeling sad than the image text pairs describing classroom behavior that are less common in real world data. So now moving on to conclusion. Compared to conventional visual emotion detection tasks, learning engagement detection tasks are more difficult for VLMs. This is primarily because engagement analysis relies on interpreting the interactions between individuals and their surrounding environment, whereas emotion detection is largely focused on the individual alone. Second, the most challenging factor for VLMs to process learning engagement detection tasks arises from the scarcity of relevant examples in real-world unlabeled corpora. Unlike emotions, which are often expressed through both visual and textual cues, engagement analysis relies heavily on common sense understanding. The lack of explicit training instances may contribute to the underperformance of VLMs in detecting learning engagement. Thank you for listening.